So let's try to understand what is a digital image. An image is a two-dimensional function which can be represented as f of x and y, where x and y are the spatial or plane coordinates, and the amplitude of f at any pair of coordinates x and y is called the intensity of the image at that level. Okay, so let me try to explain you what this means. So let's say if this is your image, okay, this is the framework of your image, and there is an image, let's say such kind of blob is available on the in the image. Okay, let me highlight it. I'm not good in this, but I'll try my best. So let's say this is the image that you have. Okay, that is the digital image. Now as per the definition, what it says, that an image is two-dimensional function of f of x and y. So whenever I say this, whenever I talk about this image can be broken down into, let's say if I take this as an axis, okay, let's take this as an x, this as an y axis. Okay, this image is nothing but it is a function of x and y. Okay, and x and y is what? It is a spatial distance. So let's say if I want to uh, talk about this point, okay, this point over here, how can I define this point? So this point can be marked, or this can be defined using this, you know this point on x-axis and this point on y-axis. Okay, so this, let's call this as x of I, and this, sorry, okay, x of I and y of I, and the color at this location would tell me what is the value of f. Okay, this f is what? It is the amplitude of the intensity that this particular spot represents. Okay, and collection of all such points is nothing but your f of xy. Okay, and this is nothing but the definition of a digital image. Okay, I hope this makes sense to you. If you're not clear, you can unmute and let me know. Okay, I'll explain it one more time. Okay, so if x and xy and amplitude value of f are finite and discrete quantities, what do you mean by finite? Finite means it is not it is not infinite. Okay, it has a definite start. So in this case it is o, and the end is over here. Okay, let's call this as x of n. Okay, this has, let's call this as y of m. Okay, so it is both finite in both directions. Okay, it is not infinite, it is finite in both the direction, and the values take discrete quantities. Okay, it takes some value between these numbers. Okay, so you will have, you'll have a minimum value or minimum distance that you can travel in x direction, and minimum distance you can travel in y direction. Okay, so if you take that minimum distance and draw a block like this, that would be nothing but your pixel. Okay, this would be called your pixel. So I'll write it down over here. It is nothing but pixel. Okay, so this is the meaning of finite and discrete quantities. So what is a why do we say discrete quantity? Because it's distance in x direction and y direction, the minimum value that you can travel, or you can uh, define or transfers in a given image, is limited by the pixel, which has a definite width and definite length. Okay, and if these two uh, criterias are fulfilled, only then we call it as a digital image. Okay, an image would be called as a digital image when it is in two-dimensional function defined by f of xy, where x and y are spatial plane coordinates, and amplitude f defines the intensity of the image. Also, the amplitude value of f, x, y, and f are finite discrete quantities. Only then it is called as a digital image. Okay, now we know that why x and y should be finite and discrete, isn't it? Now let's talk why this f needs to be finite and discrete. Why this f value is finite and discrete? Because usually in a computer system or any standard that you may pick up for colorization, we have defined that a value of a color can take anything between 0 to 255. Okay, so this is a standard that we have agreed upon. आता ते हेच का स्टँडर्ड ॲग्री का केले आपण? Now, so there are many pros and cons on accepting this values, which again is beyond our syllabus. What is important for us to understand is that the intensity values can only vary between 0 and 255. Okay, in our decimal system. Now this can again be converted into binary form. It can also be converted into a hexadecimal form. Okay, but the numbers will, the maximum number that you have is between 0 to 255. That is, in total you will have 256 intensities. Okay, number of 256 intensities, that is f values. These are again, these are finite and these are discrete, because you cannot go 0.1. Okay, you can only take values between 0, 1, 2, 3. That is, you can only take natural numbers. Okay, and dot 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 up till 255. So that is why it is said that x, y, and f values, f is nothing but your intensity, it takes a finite and discrete quantities. Okay, any questions with respect to all these definitions?
No,
If
sir.
there are none, okay, thank you. I'll go to next slide. So this is the first digital photograph that was taken. It is of a child, and it doesn't look that sharp, but this is the first digital image that was available, and you can see that the 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 image is grayscale. Till then there was no provision or facility to get a color gradient, and we'll see how an image is actually how it acquires colors. Okay, so let's consider this image. Okay, how an image is represented. So if we take this point over here, okay, so this point, if we take this point, it is defined by fxy. Okay, let's consider this point as 1 comma 1, and this point over here as 2724 comma 2336. That is, this value represents the y x value. Okay, and this represents the y value. So this is nothing but the location here. Instead of using conventional coordinate system, what we have assumed is that, or the assumption is that, if you go in this direction, your x will be positive, and if you go in this direction, your y will be positive. Okay, this is just an assumption. You could have taken any other way. You could have assumed this to be 0, this to be 0, any arbitrary point as 0. It is again up to you. In this particular example, it is considered that this point is considered as x, that is 1 comma 1, and this is considered as 2724 and 2336. Okay, so now what is the function of this, that is, what is f at this particular location? It is 1 comma 1, that is first pixel. What is the intensity? It is 103. Okay, now again, there are various ways in which you can represent this color intensity. Okay, you can write it in terms of RGB. Okay, which is very famous, and most of you would be aware of this way of representing. So when I say, like I said, we have 255 as max. Okay, so when I say 255 comma 0 comma 0, okay, this means that I'm talking about bright red color. Okay, when I say 0 comma 255 comma 0, then the output, okay, in this case it is going to be red, in this case it is going to be green. Okay, and when I say 255 sorry, 0 comma 0 comma 255, it is going to take blue color. Okay, and we know that if we combine various colors, it is red, green, blue, in different intensities, okay, or you must have experience of this in your school days, when you used to mix two intensity of color. If you take some red color and more of green color, then some particular it would result in some different color, isn't it? So if you take green color and if you take yellow color, it would result in blue color, something like that, isn't it? So this combinations would give you different types of colors. Okay, so here it is mentioned only in single format. Another format is to mention it in RGB values. Another format is to write it in hexadecimal. Okay, so you can represent these in hexadecimal manner as well. The representation is again up to you, how you wish to represent your data. You can represent, in this case data is our color, and that color is represented by a single value. It can be represented in a array format. Okay, and that array can be of red, green, blue, or it can be in the form of hexadecimal single value. Okay. So consider the following image, which is of 2724 comma multiplied by 2336 pixels. Okay, so these are the number of pixels that are available, and it is assumed that 1 comma 1 is the size, one in this direction, one in this direction, 1 unit is considered as the width and height of the pixel. Okay, in 8-bit representation, pixel intensity value changes between 0 to 255. So what is the representation over here? It is 8-bit. Okay, like I said, you can have RGB, you can have hexadecimal. Similarly, you can have 8-bit representation, where 0 is black color, 255 is white color. So this is again, you must have studied that absence of any color is nothing but black color. And whatever white light we see in the natural light that we are exposed to is combination of all the colors. Okay, that is 255 intensity is the combination of all the colors, and that would result in white color. Okay, so let's say if I take this part of an image. Okay, image मी एवढंच part घेतलं, and if I want to understand how to represent this particular part, because what a computer can understand, or any processor or any electronic uh, equipment can understand, is nothing but zeros and one. Okay, so if it has to be converted into a zeros and one, that is in binary format, first it has to be converted into processor format, and processor format is nothing but again numeric values. And how do we do that, or how do we simplify that, is let's assume that we take this bit of uh, image. Then we will define the intensities for this x direction and this y direction uh, uh, pixels. Okay, so we know that one 1 unit is going to be 1 unit, 1 pixel. So this 64645 is nothing but this value. Okay, over here, x direction, sorry, this is x and y. So from 645 to 650, so this is 645, and this is 650. Okay, similarly this 13213 23 is nothing but y in this direction, and 1328, it is in this direction. Okay, in y direction. So what essentially we are doing is we are taking 6 values. Okay, 645 to 650 is 6 values. Okay, six values in x direction, 6 values in y direction, and that is nothing but we are talking about 6 pixels. Okay, and what is the intensity of all these all these pixels? It can be given in this array format, sorry, in this matrix format. Okay, so let's say if I want to find the f of, let's say f of 646 comma 134, let's say, okay, 1324. Can anyone tell me what is going to be the intensity of this pixel? 646 comma 1324. Yeah, 82. Yes, so it is going to be this value. Okay, 82. Why this value? So this is in x direction. Okay, this is x direction and this is y direction. So what is the first x? It starts at 645. So you take this value. This is going to tell you about 645 comma 1323. Okay, this value is the intensity at 645, sorry, 646 comma 1323. Okay, then what is this value? This value tells you about 646 comma 1323. Okay, then if you come in one pixel down in y direction, then you start with 164 comma 1323. Then this value would be 1 in x, 1 plus in x direction, 1 plus in y direction, so it will be 1646 comma 1324. Similarly, how can I express this? It can be expressed as f of 650 comma 1328. Okay, it is given as 77. This value is given as 77. Similar, the last pixel which is given by this value is nothing but 88. Again, now you must be having a little bit of confusion of how to understand these numbers. So for to help you out with this, what I have done is I have included some references. If you go to this reference, first reference, let's say, okay, so I'll remove all these things. It is not required at this point of time. So if I run this now, let's see. See, this is in the format of RGB. Okay, so first the maximum value 255 is for what? It is for red, 0 is for green, and this 0 is for B. Okay, that is blue color. Now your green and blue colors are 0 0, and your full intensity is for R value. So the output is nothing but red color. Okay, so let's say if I give 0 over here, and if I give 255 over here, what output should I expect? ये कलर कौन सा हो जाना चाहिए?
Blue.
It should turn into blue color. Okay, similarly, let's take some combination. Okay, let's say this is 150 blue and green. Let's see what this looks like. It has taken some color, which I am also not sure what color it is. Probably if would ask my wife, she can tell you the differences in colors. So this is going more towards green. So if I give 250 over here and 250 over here and on this, it is slowly becoming yellowish. Okay, so the link is there in the presentation. You can go and you can play around with these numbers, and uh, you will get a hang of how these colors are generated. Okay, तुम्हाला थोडीशी एक अंडरस्टँडिंग येईल की हे नंबर्सने कलर कसं दिसतंय. Okay, so there is another link which talks about hexadecimal numbers. Okay, so this representation is, so what we saw over here, it is 8-bit representation, okay, which is in grayscale. Now this is in RGB format, which gives you colors, and another way in which you can represent the colors is in this hexadecimal format. Okay, so again, the link is there in the slide. You can go, you can click on it, and you can visit that. Okay, why it's not opening? Okay, it has opened. So you can see that, let's say the hexadecimal numbers are represented in this fashion. Okay, you have these 6 places wherein you can, the values it can take is from 0 to 9 and from A to F. Okay, so I can, let's say, give A, then 0, 0, 0. Let's see what is this color. Okay, this color is different. Then what is F, F, F? Okay, if I take all F's, then which color should I anticipate? Any ideas? It should be white. Okay, since it is white in color, the text has gone, so maybe I can uh, give this as 0, 0, 0 for the text, and then it is visible. Okay, white background in black text. Okay, so don't worry, this is not going to come in your exam. This is just for you to understand how the colors can be coded into numbers. Okay, if you play around with this, uh, you know it will be much better for you to understand this subject much more in a better fashion. Okay, any questions still here?
No, sir.
Okay. So remember digitalization, or sorry, it is digitization. Okay, remember digitization implies that a digital image is an approximation of real scene. So you have to understand this is just an approximation. Why approximation? Because if you zoom this image at this location, you will understand that it is not made up of, like, imagine if this was an actual material. Okay, if I was to zoom in this area, what would happen? Then probably if I zoom it too much, probably I'll be able to see the surface texture of this material, isn't it? If I even zoom it much further, then probably I can see the microstructure of this particular material. But what we are doing over here is nothing but we are doing an approximation in case of digitization. Okay, whenever we say image, you cannot zoom in to infinity. Okay, you only have you can zoom in only till a certain extent, after or beyond which you will see the approximations done. So what are the approximations? The approximations is the pixel. Okay, the pixel can take only one value, it can take only one intensity. Okay, okay, so this box is nothing but pixel. If I'm not sure if you can see, so most of you are on mobile, uh, but if you zoom in any image, okay, that you have, you will start seeing boxes. Okay, that each box is nothing but your one pixel. Okay, and that pixel can have only one intensity. And so if you really want to improve this quality of the image, what you have to do is you have to reduce the size of the pixel. Okay, so for the nomenclature, what we will do, since this is uh, an MTech class, especially in second semester, you should develop a habit of reading papers. Okay, so what we'll do is, in some of the classes we will read research papers together. Okay, so for this nomenclature part, we are going to read this research paper. It is a review paper on overview of image processing. The author is KMM Rao. He is a deputy director at NRSA in Hyderabad. So let's read this through. Okay, so this I will upload on the Moodle page as well. And I'll not read through the entire thing, but I have highlighted few of the parts which are important for us to understand. Okay, so the first important thing is, what is image processing? So the image processing is a technique to enhance raw images received from cameras or sensors placed on satellites, space probes, and aircrafts, or pictures taken in normal day-to-day life for various applications. So in short, what is image processing? Image processing is nothing but a method or a technique to enhance or to improve the image that must have that any sensor may have received. Okay, then what are the various applications of image processing? The various applications of image processing are remote sensing, medical imaging, non-destructive evaluation. So this is relevant to manufacturing. Okay, you as a manufacturing student, this is important for you. Non-destructive evaluation. So forensic studies, textiles, material science. Like I said, I gave you an example of of microstructure. So yes, we can study microstructure thanks to SEM images and TEM images. So scanning electron microscopy is used to measure or to explore the material characteristics, and that comes under the umbrella of material science, which is an application which uses image processing. Okay, then in military, uh, so you must be aware of drones. So those drones, if they capture live images, isn't it? And the images that are captured by the drones usually are not of a very good quality and which needs to be processed. So those usually are done in military applications. Then in film industry, of course, to do shooting. If you want to take a sky shot, then you use various techniques to get those. Okay, then document processing. Most of you must be using some form of an app that scans pages for you. So that is nothing but document processing. Sometimes you convert text to image, image to text. So those are nothing but document processing. Graphic arts, some of you must be using AutoCAD or stuff, that is nothing but graphic arts. Then printing, also some of you must also have used Photoshop. Okay, that also comes under graphic arts. Then printing industry, of course. Okay, so these are the applications of image processing. Then what are the common steps in image processing? The common steps are image scanning, storing, enhancing, and interpretation. Okay, so these are important, you have to remember these. What are the common steps in image processing? It is image scanning. Scanning is nothing but you read the image. Okay, then storing, that is you convert the whatever you have read. Especially when we are talking about digital images, you take the image, then it is digitized. Okay, that it is before storing it into the memory, it is converted into digitized format. Okay, then it is stored in your memory. Then you may enhance it, and you can do interpretations. Okay, so this is an optional step, but these are the common steps that are followed when we are doing any image processing. Okay, then till now we have only been talking about digital image processing. Then what is analog image processing? Analog image processing refers to to the alteration of image through electrical means. The most common example is television imaging. Okay, so if you are aware of the working how this television works. Okay, especially the CRT TVs which used to be in bygone days, uh, those used to excite film that is available on the screen. uh, and the rate at which it used to scan the this entire screen was the refresh rate. Okay, so what happens in that is, uh, you used to focus a stream of beams onto the film so that it would excite that particular pixel, and it would give out the color depending upon the intensity or the amplitude or the voltage that is being provided with each of the electrons. Okay, so that is nothing but your analog image processing. Now what is digital image processing? It is in the term digital image processing generally refers to processing of a two-dimensional image by a digital computer. Okay, in a broader context, it implies digital processing of two-dimensional data. The digital image is an array of real numbers represented by a finite number of bits. The principal advantage of digital, I have also marked some important questions that may be relevant from your exam point of view. So it says why digital image processing is preferred over analog image processing. uh, Again, there is depending on the applications, you either have to go for analog or for digital. There is no option as such, but if you do have an option, why would you prefer a digital image? Is because simply it is versatile, it is repeatable, and it preserves the original data precision. Okay, so these are the benefits or advantages of carrying out a digital image processing. Now, what are the various techniques in image processing? So these are the most common digital techniques that are there uh, in your image processing. That is image representation. That is, if you receive information, how do you represent it? Okay, let's say if you represent a colored image, you may represent it in grayscale. Okay, or you may basically you may treat upon the data and represent it in a certain format. Okay, so image representation and image pre-processing, image enhancement. So don't worry about all these words at this point of time. Just remember all these words, and in detail we are going to study all this, if all these techniques. Okay, image processing, then image enhancement, image restoration, image analysis, image reconstruction, image data compression. So let's talk about image representation. So image is defined in the real world is considered to be a function of two real variables, for example f of xy, where f as an amplitude, that is brightness of an image at real coordinate position x and y. So this we have already seen in the slide number 1. Okay, so this is how we define an image, especially a digital image. Okay, so here again the explanation is given of how, if you take this box out, this can be represented in a matrix form, and the values are nothing but, so this value is nothing but the f value or the intensity at this location. Okay, then this is intensity at this location. So 0 means black color. Okay, you can see wherever there is a 0 value, there you have a black color. Okay, and wherever you have 255, there you will have a bright white color. Okay, so a 2D continuous image f of xy is divided into n rows and m columns. The intersection of rows and column is called as a pixel. So this also we have seen. Okay, now what do you understand by scaling? uh, so what I'll do is we will stop for here today, because there are only 4 minutes for of the time remaining. In this time, what I wish to do is I want to know if you have any questions.